Hey, Miss Rueckert's Pre-AP. Here is your Chapter 4 notes continued on Section 4.8, I believe, ions and ionic compounds. So I guess it's 410, ions and their compounds. Reminder that atoms are always neutral. That's why if we know the number of protons, we know the number of electrons. So atoms are neutral. When we look right at the periodic table, we're going to assume they're atoms as written. Today we're going to introduce you to ions. So the definition of an ion is an atom or a group of atoms that have a positive or negative charge. So an atom or group of atoms that have a positive or negative charge, and that charge that it comes from is based on the number of electrons. So ions are created by gaining or losing electrons. Now remember that the identity of an atom is based on the proton number, so the proton number cannot change or it's not the same element. The number of neutrons determine the isotopes. Now we're on to electrons, which determine behavior, so if they gain or lose electrons they're called ions. A cation. A cation, if you like cats, it's a positive thing. If you're Miss Rueckert, you're just faking that because my philosophy is the only good cat is, well, okay, I'm not going to finish it. But cations are positively charged ions. So it's positive ion due to the loss of electrons. Since all atoms have the same number of electrons and protons to start with, if they lose an electron, means they'll have more protons in the nucleus than electrons on the outside. Therefore, they'll have a positive charge if they lose electrons. Since they're losing electrons, cations tend to be smaller than atoms, than the neutral atom they came from. And most metals lose electrons. If we look at the periodic table, we said that the metallic side, group 1, has 1 electron in the valence letter, in the valence shell. So therefore, is it going to give up 1 or lose 7? Gain 7 electrons to become that neutral 8. We said that the group 1 will lose 1 electron. Group 2, if it wants to be stable, needs to get 8. Is it going to give up 2 electrons or gain 6? It's more likely that it's less energy to lose 2 electrons, so they become positive. So metals tend to have 1, 2, or 3 electrons in the outer level, so they lose those 3 electrons to become cations. So examples, sodium becomes +1 because it's in group 1 and it loses its 1 electron. Magnesium is in group 2, so it loses its 2 electrons. Aluminum's in group 3 with 3 valence electrons, so it loses those 3 and becomes aluminum +3. So notice the charges are put on as superscript, and a positive indicates it's a positive charge. So anions. Anions are negative. So I'm not trying to pick on anybody, but sometimes I like to make mnemonic devices. So if you don't like a person named Anne, it's a negative thing. I'm not trying to pick on anyone, just going to say that's how I remember it. So anions are negative due to the gain of electrons. A refresher that atoms are neutral, so if they gain electrons, they're going to become negative because there's more electrons, which are negative, than protons, which are positive in the nucleus. Since they're gaining electrons, they're usually larger than their neutral atom they started with. Because they gain electrons, they get bigger. If you look at this diagram over here on the left, on the top I have cations. So if the neutral lithium is in the dark green, the orange color is lithium +1. When it lost that 1 electron, it got lots smaller. Whereas sodium doesn't quite get that, but you can see there's a difference between the neutral sodiums, and when they lose an electron they get smaller. Whereas the anions on the bottom, I have oxygen, which is the neutral oxygen is the little green, light green one in the center, and oxygen -2 is the anion. When it gains those 2 electrons, it gets bigger. So on the bottom, the ions are the ones on the outside getting bigger. Nonmetals, which are on the right of your steps of your periodic table, are usually anions because nonmetals have lots more electrons in the valence shells. They usually have 5, 6, or 7. Therefore, it's easier for them to gain more electrons to become that neutral, or the stable 8 than it does to lose all of them. So, examples are chlorine is a halogen. Since it has 7 electrons in it, it wants to have 8 to be stable. It's easier to gain 1 than give up 7, so chlorine becomes -1. Oxygen would rather gain 2 to become -2 than lose 6. And nitrogen has 5 electrons in the valence shell, so instead of losing all 5, they gain 3 to become a -3. Again, notice when you do anions, you put the negative in there for negative charge. So compounds that contain ions are called ionic compounds because they have ions. And ions are charged, just so you know that all electricity things, anything needs to move. So electricity is conducted when something can move. Right now you guys are watching this thanks to wires in your computer and in the lights. Wire conducts electricity because it's a metal, and the transition metals work really good as conductors because their electrons can move. So copper is a good conductor. That's usually what's in your wiring system of your house and a lot in your computer. Platinum is even better, but it's more expensive. And gold is awesome, but I don't want to pay for that. Ionic compounds conduct due to charges. So when you put ionic compounds into solution by putting them into water, the ions freeze up. So if we look at the bottom picture here, you're kind of looking like a battery. A battery, like you think of a car battery, has a solution in it, and they have these rods in there, and those rods will conduct electricity as long as the solution is replenished with that. So if you look down here, chlorine is given off as a gas. There's copper 2 solution in there, and copper's is deposited. So it's kind of how a battery works. When you hear about corroded batteries, it could be because there's solution in there that doesn't get changed. So how do we write formulas for ionic compounds? Compounds are neutral, so we need a net charge of 0. Atoms are neutral, compounds are neutral. So since compounds are neutral, we're going to try just to have a net charge of 0. So if we're going to deal with ionics that have ions in, we're going to have a positive cation with a negative anion, and the charges will equal 0. So we're going to put a cation and an anion together. A common one is your NaCl, sodium chloride. The question is why do we write NaCl? I know you guys understand it's one Na atom and one Cl atom, but why? Well, if we look at the charges, if sodium loses an electron, it becomes a +1 ion. And chlorine gains an electron, becomes -1. So the question is, do those charges equal 0? In this case, yes. So that is why it's written NaCl. So if we look over here on the picture that just came up, on the left, on the top is a sodium atom, and on the right is a chlorine atom. If we look below, the sodium ion, notice it's in brackets, lost an electron. You can see it up on the top, it's not there on the bottom. And that one lone electron, that bluish green thing, is now gained by the chlorine to become NaCl. So that's the compound. So the cation gave the electron to the anion, and that's why they're a stable neutral compound. Magnesium chloride, if we look up magnesium, is in group 2. So it loses 2 electrons to become Mg+2. Chlorine, again, is a halogen. It gains 1 electron. So if I look up Mg+2 and Cl-1, they do not equal 0. So I'm going to need to have 2 chlorines, and that is why I have MgCl2. So basically all we're doing is looking at the subscripts and figuring out looking at the superscripts as far as the charges, see if they equal 0. If they don't, we can add subscripts until they do. So think of common multiples. Here's some examples for you. Write formulas for these. Sodium and bromine. Sodium is Na, and the charge becomes +1 as an ion. Bromine is a halogen, Br, and it gains 1 electron to become -1. So the question is, do those charges equal 0? Yes, they do. +1 equals -1. So it's NaBr. The second example is iron 2 and chlorine. So little note there, that Roman numeral 2 means that's what charge it'll take. Transition metals take various charges because that's why we didn't assign any to them, because they can have 1, 2, or 3 electrons in the outer level. So they'll either gain 1, 2, or 3. They're usually always positive, but it depends on the charge. I think I gave you a pink or green sheet a while back with the elements and their names on the front, and on the other side there was a bunch of compounds or ions. Now you'll know what that means. So iron 2 means it's a +2. Chlorine again is a halogen, so it's a -1. So the question is does +2 and -1 equal 0? I don't think so, so what can we add to get it to equal 0? If I put a 2 with the Cl, -1, it'll be -2, then +2 and -2 will be 0. So that is why we write FeCl2. Calcium and phosphorus. Calcium is Ca, phosphorus is P. Calcium is in group 2, so it takes on a +2 charge. Phosphorus is in group 5, so it's going to gain 3 electrons to become -3. How do you balance Ca +2 and P -3? They do not equal 0. So what is the common multiple of 2 and 3 is 6. How do I get the Ca +2 to be 6? I take it times 3. How do I get the P -3 to be -6? I take that times 2. So I write Ca3, P2, because then my charges will equal 0. Thanks, have a great day.